Okay, welcome to another in the series of talks about Edge. This time we're going to be talking about all the different components, and we can argue about which are the best ones. So we're going to be talking specifically about the workloads and how that changes as you move out to the edge, and the many options that are involved. And with that, we'll do quick introductions. So I'm Beth Cohen, and I'm one of the co-founders of the Edge Computing Working Group in OpenStack, and also we have a commercial product that is based on Edge. Of course, we didn't call it Edge when we created the product, but it's a telecom network services product. And we have smacked into all the interesting issues with deploying at the edge.
Hey, I'm Ian Wells. I work at Cisco, and I've been doing NFV for altogether too long at this point, long before it was fashionable, or even called NFV. Practically speaking, when it comes to NFV, then you're always looking at use cases where you're trying to get the value out of the footprint of a service provider's network. So it always comes to edge, closer or farther away as the case might go. So I've been exploring these problems as part of my day job for an extended period of time at this point.
Hi, my name is Hilda Covant. I'm working for the OpenStack Foundation. My title is Ecosystem Technical Lead, which is really mysterious. So I work together with our ecosystem members and try to help them succeed with OpenStack, both as software package and also as community. So I'm doing a lot of onboarding activities. My main focus areas are telecom, NFV, and what a surprise, Edge. Oh, and I promise no kittens will die during this session.
So my name's Chris Price. I work at Ericsson, and similar to Ian, we have an objective to provide edge technologies to the market so that our customers can leverage them.
Allison Randall. I'm currently a PhD student at the University of Cambridge, working on hypervisor optimization in edge context. But before that, I was Director of Engineering and Distinguished Engineer at both SUSE and Hewlett-Packard on OpenStack.
Okay, so with that, let's dive in, because this is a big topic, and we only have 45 minutes. So one of the things I'd like to ask the panel is containers or cloud, or something else?
Or both.
Or both.
It's usually me who gets to go first on this.
No, you don't have to.
Oh, I like going first on this. And the answer is, they're nice. We like them. The simple fact is, if you look at containers or clouds, or virtual machines, let's be honest, then, or sandboxes, or Lambda functions, or whatever you kind of choose, they've all got their strengths and weaknesses. You wouldn't, pick a language and then decide what you're going to program. You would ideally decide your problem space and then find a language that suits that when you're programming. And I think the same applies to edge use cases. Sometimes it's a container because you simply haven't got the space for a virtual machine. They're kind of big. Sometimes it's a virtual machine because it defends itself better against other things running in the same system. Virtual machines, if I'm running virtual machines from two different suppliers, I can't have them pointing at each other and saying it's their fault. Because I'm a service provider and this is not making me money, and it's certainly not making me happy. So there are reasons for choosing different things in different circumstances.
I would just say that, reflecting to the point that it should be depending on the use cases, I would also say that VMs and containers and cloud and all these things, we shouldn't pick one and go with that and that's the only thing that exists, but rather having an environment where they can coexist and basically ensure that in our infrastructure they are integrating well.
So the fundamental problem with the question is it assumes that cloud and containers are the only options, although you allowed for possibilities elsewhere. So my research, I call it hypervisor optimization, but it's actually more in the hybrid space. If you go back to the beginning of virtualization, the goal was for it to be both secure and performant. And somewhere along the way, we lost that. And now there's this bizarre idea that, well, if you want secure, it can't have performance. And if you want performance, it can't be secure, which is from a software perspective, ridiculous. So you'll see there are quite a few projects out there right now. Kata Containers is one. There's a really amazing research paper on Zen. The title is "My VM is lighter and safer than your container." And I tend to describe them as hybrid approaches. So instead of looking at it, you know, like I don't know, like a Vim Emacs war or something, it's like, oh, it's cloud or containers, it's VMs or containers. Just look at it generally as the concept of composition, that services are composable, that the hardware machines that you run software on, you don't look at them as a black box, but they can be composed of different pieces, and those pieces may be VMs, they may be containers, they may be functions, Lambda, serverless, and abstract away from all that. And all you're looking for is that we want our technology to provide isolation, secure isolation in a highly performant way, and we want to make it easier to deploy services. And Edge needs both, like all of those things, the same as data center workloads need all of those things. And as they get performant, all of the new technologies in that space will be usable on Edge exactly as they are in the data center. In the data center, you want increased performance because it saves you on power and it saves you on the amount of hardware you need to purchase. On Edge, you have that, but then you also have, as Ian mentioned, the constraints that in many cases you have much more restricted hardware than you would in the data center. Basically, just the answer is right now, yes, you end up having to choose between VMs and containers. In the future, you should not have to, and if you do have to, we've done something seriously wrong.
I think another way of answering the question, the technological answer is yes, and even in the future, a better yes. The ops question is, how am I going to operate my edge, and what are the constraints that I'm under when I'm trying to operate on my edge? To quote the ghost of OpenStack past, we don't want pets, we want cattle. From a network operator's perspective, I may have 100,000 cattle that I need to ship out, but in the context of one edge, that's probably a pet. And we need to sort of correlate between, you know, how we manage the ops versus how secure and stable we need the workload to be in any given context. And I think that's one of the challenges we see as you move out to edge. We talk about constrained resources and we talk about these sorts of things. And what that really means is how we deal with the workloads is a little different than we would in a very large cloud. And in that context, VMs are just as effective as containers or maybe even hybrid solutions as they come out. Or even Lambdas, they still need to be maintained, operated, and lifecycle managed in an effective way. How you package and run that is really a question of how you want it to behave at the end of the day.
Just two administrative notes before we move forward. There are a lot of seats here, so all of you who are standing in the back, please feel free to grab one. And the other thing is that Beth will ask amazing questions, but if you think that you have even better ones, there are 2 mics in the room, so please be active because, you know, the panel is only good if we are all grilled a little, so please.
Yes, I agree. I agree. So the next question is which gets to the heart of the matter, now that we've talked about the, you know, sort of the different options, how do you make a decision based on your workload? What are the types of workloads that might swing to one way or the other? And I can answer my own question for me. So network services applications are currently swinging mostly to the VM side. And that's because the vendors have frequently not containerized for a variety of reasons. And I'll use the one that I most commonly run into, which is firewalls and security services. When I have spoken to the vendors about containerizing their applications, the answer usually starts at no to hell no or never in your life.
So I get to play with VNFs on a regular basis. There's a couple of problems here. One is what containers are. Containers today, you look at Kubernetes, right? OpenStack was, particularly the networking of OpenStack, was designed by a bunch of network engineers, and it shows. So it's very, very plain how wiring works networking, very much how you would wire a data center up. Kubernetes networking was designed by application engineers, and it shows. So really, when you're talking about Kubernetes networking, it's absolutely fantastic at getting you your TCP socket handed off to your application. All of the networking comes through the kernel TCP stack or the kernel UDP stack. And that's intentional and deliberate, because I'm trying to reach a service, I'm trying to get the service to answer me, and I'm trying to get it to answer me using boring old protocols that we use every day in programming. When I'm trying to do something like a firewall, or most VNFs, and it's not exclusively everyone, there are always counterexamples, but a lot of these VNFs we deal with, they're trying to run packets from A to B as fast as possible, and they want to look at every single packet. And that means the packet. It doesn't mean the TCP flow, and it doesn't mean I want to assemble them and then break them back up again afterwards. It means I actually want to look at every single packet, just like an ASIC in a router would do. Kubernetes doesn't give me packets. You can just about make it give you packets. It would be a battle. It would do a very bad job of it. It would be desperately, desperately slow, and Beth would not buy my VNFs if I did it. So that's not going to work. Now, we're looking at this in the Kubernetes community today with a thing. At the moment, there's a project called Network Service Mesh, which is looking promising on this, and other interfaces that in Kubernetes, since we have an interface for application networking, it's logical that we might want an interface for packet networking that's a separate and different beast that I might want several of, and split the job up into 2 bits so that I don't break the application side of thing by doing the thing I need for real hardcore networking use cases. But at the moment, you aren't going to see VNFs in containers, because certainly the high-performance VNF, firewalls being a fine example of the category, are not capable of running that fast in containers. They can't do that. The infrastructure's not there for them just yet.
Well, setting aside the issues that explaining to our customers about the security of it, yeah, containers are reasonably secure, but it's a different concept of security, which, in the financial services industry doesn't cut it. So.
If I'm deploying an application towards the edge that's going to do video analysis and tell me how many cars are driving past, or number plates, or random things like that, I'm going to use containers for that. It's a nice way to package. It's a nice way to lifecycle manage. I can deploy. I can scale. I can do whatever I need to do depending on how many cars are driving past. It's awesome for the job. So it's not that we're saying one is wrong or one is right. It's a question of what are you working on at the edge? What are you deploying? Yeah. And what is the right tool to help that happen?
Yeah, and let's be clear, right? We keep having to, I personally keep having to remind myself that the network edge is not the edge. The edge is, it can be a branch office, or it can be, your local McDonald's. It can be their bookkeeping systems or whatever. It can be a lot of things, and while networking doesn't necessarily suit containers terribly well today, I mean, it's not true for every application you'll see. Mm-hmm.
No, retail in a box is actually an excellent way, excellent use for, that would point to containers for me, because those tend to be applications that are written for the company, and so they're quite, there's nothing stopping you from making them containers right from the beginning. And of course, anything that involves, triggered type applications, Lambda or containers is a more obvious, appropriate use.
And I think IoT would go the same way. IoT is still a kind of growing industry, and a lot of the code is new. There's no reason to believe they wouldn't, write their stuff as containers. If you're sitting there with a clean slate and you think, I want to architect something, it's a very, very good place to start with to design an application well. But if you've got a whole bunch of legacy stuff, like as in the networking world, among others, then you're probably stuck with what you're stuck with.
You might, you could potentially be running a Lambda service for IoT within a VM, for instance.
Oh, yeah, absolutely.
But anyway,
these things are not incompatible.
No.
It's just the last thing on top is the thing that you care most about, almost.
One thing that I think is worth mentioning and sort of coming to terms with is that the choice of workload is one thing. The operation of a network that happens to have edge is of primary importance. I keep talking about ops. I'm an ops guy now. But anyway, one of the topics that comes out in this OpenStack summit is open infrastructure. And we talk about open infrastructure because we're not talking about building data centers anymore. We're talking about a ubiquitous infrastructure that addresses different aspects and parts of the network. And I think it's really important to sort of look at, when we move towards the edge, how do I treat that little thing sitting over there the same way I treat my data center, how do I make sure that when I log in there, I don't need another AAA service, or I don't need another way of handling images, or I don't need another something else, regardless of what type of workload I'm running. I think it's really important to sort of carry that forwards. The operations, let's not create pets out of the sites. Let's make sure they're cattle as well.
Yeah, I only have to write the application once and deploy it 1,000 times. So writing the application is the easy thing. But when I deploy it 1,000 times, I have to look after it 1,000 times.
Yeah, and that's where automation comes in, and very, very much so, even more so than within a data center, because the automation is over, it's over a federated network, it's over intermittent connections, it's whole sections of the infrastructure might well, be off the network for a period of time, and we need to have those tools to be able to support those types of workloads. And Allison's been very quiet.
Well, I don't really have a very good answer for this question. I think, yeah, so it just comes back to the composition perspective, in that the big change for Edge is not thinking about the location that you deploy your workloads to as a location. And it's almost like your clouds have become little objects out floating in the world, encapsulated objects out floating in the world. And your entire cloud, or Kubernetes cluster, whatever, is now a thing that you have to manage like you used to think about managing a server. We used to think about our servers as pets, and then we got to the idea of thinking of our servers as cattle, and that's great. But we still think of our data centers as pets. And with Edge, you kind of have to take the meta step up and start thinking about your data center, which could be like 4 little boxes sitting in a cell phone tower. Your data center is cattle now. Your entire cloud or your entire Kubernetes cluster is cattle, and you have to start thinking about that in an entirely different way.
Yeah. Oh, we have some questions. We have some questions. Thanks.
Is this on? Yeah. I have a question about, like, as we move to the edge and all of these things, like you're deploying containers, you're deploying VMs, you have OpenStack services and all of that. Like, it feels like the monitoring of all that stuff becomes a nightmare really quickly because there's no one tool that can solve it all. And so you end up being, I know we're talking about pets and cattle. It feels like, I have something to monitor these cats over there, and then I have something to monitor this cattle over there, and then I have, I end up monitoring all kinds of different cattles, but in different ways. And then, like, that doesn't talk to together.
I can answer that personally because my product has that exact problem, and we're using tools that we've been using for 10 and 20 years too.
Yeah,
so
we're still using Nagios to monitor some of that stuff.
I don't think we're using Nagios anymore, but yeah, I wouldn't doubt this someplace in our network. But the point is that we're using systems that have, the operations people are comfortable with. They're very highly tuned, and we have to integrate all this new stuff. And I can tell you, I have spent many hours doing training of the operations people, explaining how a box that has virtual services works. From a technical perspective, they get it right away, but from the conceptual, from the monitoring, and how you not only monitor, but how you react when something goes wrong, it's a different mindset. And I know the operations people in my company are struggling with that.
I suspect this is the biggest area of tools development in the next 5 years because the tools really don't exist yet. It's a big gap. Yeah.
One thing that keeps happening with us, there's 2 parts to this. One is monitoring vertically versus horizontally. If your application stops delivering, which is what you care about, then was it your application, your infrastructure, the hardware? You don't get many clues on this if you're not basically bringing all your monitoring together and trying to relate the 2 things. And that kind of level of monitoring, often you'll find applications that are monitorable or come with monitoring solutions that give you no insight into the cloud. Now, if you're running on Amazon, that's fine. Amazon don't give you any insight into the cloud. Your VM died, sorry. But if you're running your own cloud out there on the edge, you probably should be relating these things together. Horizontally, again, networking people, the number of times I've been asked for, can I have a service in OpenStack that gives me SNMP monitoring of OpenStack? That would be great because, I have SNMP monitoring because I'm a network guy and I have lots and lots of network devices and they all spit out SNMP. So obviously, if you just put that into OpenStack, I can monitor 1,000 OpenStack clouds just fine. It makes you want to cry. But the other thing that you get here is a push-pull on monitoring, right? There are two approaches to monitoring, and oddly, in I don't know how many years of doing this, no one ever seems to have decided what the right answer is. Do you get something to tell you what it's thinking, pushing its data out, or do you have to continually go back and ask it what it's thinking, so you're pulling the data in? Now, it's strange that pull seems to be quite so favored. SNMP in some ways is pull, because if I'm looking at 1,000 or 10,000 devices or clouds, I need to be pushing. Whatever's in the center just can't expand to that kind of level. It's got to be a push mechanism.
I think monitoring itself is just in itself an interesting topic. Like remembering back in the community, just the discussions and arguing about monitoring and metering. Just because both starts with an M, they must be the same thing, right? So we had at least two services trying to address one and the other, and people kept just mixing the things up. And that was just one part of the community challenges with this area. And the other part is that who monitors what belongs to which layer of this whole full stack. Like whether I have something in the cloud that monitors the cloud services, it monitors the hardware as well, where you kind of collect all this data, where you do the aggregation. And I think with Edge, it will be just even way more critical. So back to Allison's point, if that's something that interests you, then please bring your expertise and people and help us define this area, what monitoring is, and help us figure out how to do that right for Edge.
And I'd like to add, and yes, definitely. What I'm finding is that you end up monitoring at multiple levels, and one of them is at the box level. One of them is at the infrastructure, hypervisor, OpenStack, container, whatever level, and then at the VM level. And you have to understand your monitoring systems need to understand the interrelationship between them and then properly form alarms and tickets based on which part of the system failed, because it isn't always obvious.
I have the ultimate answer for this question, but I think we should take the next one.
Yes, I was going to say.
Okay. I don't mean to interrupt. This is on different lines, though. There's a lot of interest in something called unikernels, which are really something like a library OS running in a VM. In the context of a VNF, which typically is implemented using DPDK, DPDK itself is kind of like a library OS. So where do you see unikernels fitting in the NFV and Edge use cases?
So, okay, if people don't know much about unikernels, there's been a lot of research over it for about 30 years. There's a few very popular ones right now. Mirage is one, and Docker bought out a big Mirage startup. So the basic idea is instead of having your operating system be a bunch of separate executables, the basic functions like TCP, et cetera, are just libraries, and you compile them down to a very small binary. So instead of loading a full Linux image as the base image of your container or the base of your VM, you run a unikernel, which is just like, it's just like a very small binary that does everything you need from your OS. That's the basic idea. So the reason this is becoming interesting and popular right now is because of that same trying to get things much, much smaller and lighter. The Alpine Linux image that's very popular for Docker, gets things down to 4 meg, like a Linux image down to like 4 megabytes. So it's quite tiny. Unikernels can get even smaller, depending on what functions you need. And so that's why it's interesting. The tricky thing is, like, say, when you're developing your application for something like Cloud Foundry, if you're targeting a very specific application platform, you have to write your code for that application platform. And that's always the struggle with unikernels. So if you wanted to write your application using the Mirage unikernel, you have to write it all in OCaml, for one thing. and you have to write it using their specific set of libraries. So you can't just, people get so familiar with writing their workloads for containers or VMs, whichever, like in terms of having those basic Linux system features available. So they just like sort of write them in a standard way. To get this big performance improvement, you have to write them in a completely different way. And that often makes them less popular. That has, I would say, hindered the adoption of unikernels in general. So it's certainly possible to write, a network function, like any kind of anything at all that you can write for a Linux image. Any kind of application that you could write to run on a Linux image, you could write in a unikernel right now, today. It's just hasn't become very common yet because of that requirement to fit the very specific unikernel that you've created. There is a project, a Linux Foundation project called Unique, UNIK, or UN. It's spelled in a funny way, but it's a unikernel generator project. And it has taken all of the various different unikernel settings, and it gives you like automatic builds for them. So instead of having to like deeply understand each weird unikernel method, it kind of does a lot of things in an automated way for you. Mm-hmm. It's a possibility. I haven't seen it used specifically for this. So
we're saying every computer science problem can be solved with another layer of indirection, is what we're saying.
Isn't that true?
Pretty much.
It's all Turing machines.
You can't prove it false because you'll never get to the bottom of the indirection. So I'm interested that you use DPDK as your example, actually, because if you look at what DPDK is doing, moving network packets around, it's when you actually finish writing an application in DPDK, particularly when it's really heavy on the networking, they nearly all are heavy on the networking. Actually, if they're getting down to the point of, I want to pass every single packet it is possible to pass on this system, then they don't call the kernel at all. They don't make system calls. Because how long does a system call take? Actually, you don't know. And the other thing about tuning DPDK applications, if you've got one running in a virtual machine, is you pretty much have to shut the kernel out of most of the cores that DPDK is using just to get it to run at that level of performance as well. So while unikernels in general, you're absolutely right, nightmare to write for because you're busy writing for something very specific, it may be that DPDK is a thing where you could effectively substitute out the kernel because you do not need the features that the kernel provides. You've got to somehow control the application you're running. A DPDK data plane doesn't do very much if you don't tell it what you want it to do, and that usually changes over the course of time. So there's a communications channel that you need in there as well. But the actual moving of packets, that part of it, not terribly, it doesn't need kernel features.
Right, exactly. Good. It's kind of alluding to that. So DPDK itself is kind of like a library OS. And secondly, there seems to be a trade-off here. If you try to make it really small, like Mirage OS, it inhibits the range of applications you can run on that one. If you make it more general purpose, like Rampran or OSV, its footprint grows. It's almost like a container in that case. Then what do you get by using unikernel in that case?
It's always a trade-off. So, next question.
I noticed that this slide up here, which shows the a general edge computing topology, looks like pretty much every other one I've seen in the past year.
That's probably because it's based on the one we wrote for the white paper.
Where network transport is a black box.
Oh, yes.
And that's fine if you're a telco provider and you own your own backhaul and you've got your own network built on top of it. For people who will be implementing edge that aren't telcos, I'm wondering, where do you see the industry going as far as centralized network control, pulling that back to SDN in your cloud or inside Kubernetes, et cetera, to actually deploy a VNF anywhere you need at any edge?
That's a fantastic question.
So, I so have to jump in on this.
Yeah.
Because the thing you said there, that it doesn't matter if you're a telco, that's so very not true.
Yeah, that's very definitely not true.
You've never met people who want to put overlays and widgets and things in their network like telcos do, partly because it's fun, but mostly because they don't want to lay more fiber because it's damn expensive. And so they want to use what they've got to the fullest of its ability before they ever put another spade to shovel to the ground. So it's important to understand that service providers have exactly this problem. more so than you.
Worse.
Yeah. But as far as overlays go, I mean, we're really talking overlays here. We're talking about how to make clouds communicate with us. In the service provider space, it's about knitting that edge. Funnily enough, I have a talk on this later. So it's knitting that edge somewhat seamlessly as you can manage, to the infrastructure of the network without having people treading on each other's toes all the time, basically dealing with, is it the cloud's problem or is it the network's problem? In some regards, if you're over the top, if you're buying IP service from somebody, that's actually a lot easier. You just use IPsec or one of 100 and VXLAN, one of 101 overlays. It doesn't have to be complicated. I have to admit, it's not terribly well integrated with things, but it doesn't have to be terribly complicated, that sort of thing.
Do you want to talk or should? Yeah, so I'll talk from the telco perspective, and that's not a black box to telco. In fact, we are probably much more aware of just how many network protocols are out there that we have to interface with. So for the, let's say I'll use the retail in the box type scenario, it's actually much simpler because you're just going to have a network connection, whatever it is, be it straight Ethernet, broadband, DSL, MPLS, whatever it is, and that comes in many flavors. And you're just going to send your packets over whatever that network is to your other end. So in many ways, it's actually easier for you.
So I guess what I'm hearing is you don't see any sort of standardization, convergence on any particular method.
Definitely not.
Okay.
So before I chime in, first, I'm not a product manager, but the way I'm going to answer the question is the way I interpret the question is if I want to be able to run something in such a cloud, how do I order that? How do I get that to run? How do I know that I'm going to connect to various sites and that I can have authority to actually work on those sites? And that's where I think the SDN pieces and others come into it. As far as standardization is concerned, we've been working on SDN and standardization around that space for a long time. I think we're about as close now as we were 7 years ago to an answer.
Well, actually, we just put SD-WAN threw it into the mix.
It's just a marketing term. There's product managers
someone
out here
did tell you that standardization is not about writing more and more standards, right?
Yeah, it's called overlay networks.
Yeah, but at the end of the day, you're going to come to someone who's going to provide you with that infrastructure, and you're going to be able to order it, and you're going to be able to say what you want, and then they're going to have to solve that. We don't have a standard solution today, I think is really the answer, but what we'll find is as this becomes a more and more common activity, as this becomes a more and more commonly offered service, we will normalize around a few ways of doing things, and then you'll be choosing based on how these people are approaching the problem. But yeah, if you actually look at this picture, you zoom right into those dotted lines, it's actually made up of dollar signs.
So I invite more questions from the audience. You know everything? Do we know everything?
I know nothing.
So what's our next move? That's my next question.
We're going to write code. So this week, I don't know how many of you have managed to go into the sessions, but there's a bunch of sessions on Edge. And if you actually go into any of the working group sessions and sit down and just listen to how the conversations are going, they're awesome. I was in a Keystone session yesterday where we talked about how does this site relate to that site, and how do my keystones federate, and is federation the right method when I'm going into a smaller form, and how much security does that have, and what should I be storing there? And all of these conversations around the actual practicalities of being able to deploy a distributed infrastructure are thrumming. I think what we're being told as we walk into these meetings and say, hey, we have this need, is that, well, we have something that serves that need. Why don't you try it out? And then it's a question of us going back and trying it out and coming back and saying, well, here's the gap that we didn't resolve in this first conversation. But what I think the next step is, you'll start to see code coming out, and you'll start to see more reference deployments, and you'll start to see a lot more capabilities exposed in a distributed solution than we have seen in the past.
Allison, your thoughts?
So right now, it's interesting. So we have, I would say over the past years, there has been this insane explosion of different projects starting their own Edge group, working group, whatever. But Edge is not in the same kind of space as, say, cloud is, where you're like, there's these major competing open source projects out there with a complete edge computing solution that you can deploy and decide which one is better for your use case. It's not in that space at all. It's still very much in the, this is the idea space. And Chris talks about writing code. That's absolutely true. But bringing that all together into solutions, and not just, hey, here's a wiki page that says if you combine these 12 things, it kind of works for edge computing. Not like that, but like the ability to go out and say, I want to download and install an edge computing platform on these 300 different servers across different retail stores or whatever. We've got actually probably a few years before we're at that point yet.
So I would agree with you on that. So we did a first pass on the use cases, and I think we did a pretty good job of the first pass. But as it goes live in the world, then you find the gotchas, and you find the actual combinations. I use an example of my product. We have a design review board that we bring in. We make every single sales team that's proposing a solution to a customer come in front of the design review board, and that sounds like really heavy-handed bureaucracy. Well, why did we put it in? Because so far we have 312 solutions, and probably 275 are different. So that tells you there's still a huge amount of flexibility. I mean, we built the architected the product that way. That's good and bad in that it's good that it gives our customers a lot of flexibility. It's bad, and we have to manage the damn thing. So that's why we added the design and review board to really make sure that the solutions we were going to propose to our customers were not only saleable and technically functional, but also operationally supported. And that seems to me the key with this all. The operational tools are definitely behind where the technology is, and that's where these workloads and figuring out what's the best workload for the best architecture for the workload. We're still working through it.
Yeah, I would just add that, as Chris said, we already have a few components to try out, to test, to work on. Like Keystone, it already knows a lot of things, but we need people who starts to install and test it out, whether those features are really what we want or we need to tweak it. We still don't really know how it's going to scale, because here we are talking about not just 10 or 15 edge sites, but hundreds and thousands, and we have to figure out how to come up with some methods to test into this direction. We're also having a project that provides hardware acceleration framework, but we again have to put this into an environment to test it on actual hardware and see how it fits into. So where the group is. We are looking into coding and testing activities wherever the area is well-defined, while we are still working on identifying more requirements, searching for more use cases, because we kind of need to move step by step. And wherever we are ready, whichever area, we are also moving into action. Beth just moved to a slide where you can see how you can get involved. Tomorrow, there's also, I think, at least 2 birds of a feather sessions that you can attend. So join the communication, see where you can get involved and how you can.
It's 11 to 12:30 tomorrow.
Yeah, it's 11 to 12:30.
We're having a birds of the feather session.
Yeah, with the Edge Computing Group. So come and see where you can get your hands dirty.
I'm heartened by the fact that, I've been working on use cases for about a year now, and just in this conference alone, I've heard about 4 additional ones that I hadn't thought of. So I'm pretty excited about that.
So we're almost out of time. I just wanted to thank the guys that came up and asked questions, because they were awesome questions. Best questions we've had for this panel so far.
Yes. Okay. Just some cleanup stuff. Allison, do you want to, or Ian, do you have anything to add? Okay. Just some additional locations for resources. Read the white paper. It's a good place to start. We also have the wiki page and the weekly meetings, and that's it. So thank you very much. Oh, yeah, no problem.
Thank you.